everyone, this is the third video for the multi-channel analyzer experiment of modern physics. So after video 2, I suppose you already analyzed all the photos and already found all the channel numbers for all of them. So basically you filled out this part of the table. So our next task is to find out what's the energy of the unknown gamma ray sources. So to do that, we will calibrate our data. So basically we will create a calibration curve. How to do that? So for the three known sources, we know the energy and you found the channel number. So basically this table, I assume it's filled by you at this moment. And for multi-channel analyzer, this energy is directly proportional to the channel number. That means that the energy of the gamma ray photon is a linear function of the channel number. So there is a slope, and it's a fixed slope and an intercept. So it's a straight line. So we want to determine that straight line. And basically 2 points is good enough, but we have 3 points, and that's a good check, and we'll see how the data are straight line. And so now you have the energy, you have the channel number, and you can use Excel or use Log Pro to make a plot. So y-axis, so basically this column, energy of gamma ray is the y-axis, and the channel number, this is the x-axis. So and for example, use Excel, you will have a plot like this. If your data is correct, you will see 3 points, very good straight line. And I want you to do I want you to include the equation of the line and also display the r squared value. Basically, r squared value tells us how close this line is a straight linear line. So r squared equal to 1, that means 100% this is a straight line. So I want you to find this function. The goal is to use the 3 known gamma ray sources to find this function y equal to this coefficient multiply x and plus the intersect. So don't use the number I'm having here. This is just a symbol plot. So the actual function depends on your data. And once you have that function, so I want you to go back to your data. And for example, I want to find out the sort. You have the channel number, right? So now you have the linear function. And plug in the channel number, that's the x. For example, suppose your channel is 130. And plug in the x equal to 130 to find the y, that's the energy of the gamma ray photon. And this is how you find the gamma ray of the unknown photon to fill out this part of the table. So for that part, you found the energy, and the next job is to identify the isotope that emitted that gamma ray. And so you can Google gamma ray source. For example, here we have the potassium 40, and we have the cesium. And I want you to calculate the percent error. So I will just let you know the gamma ray source is due to potassium 40. So the unit here is kilo electron volt. So that's basically 1.46 mega electron volt. So you will expect your theoretical value of the potassium 40 is 1.46. And also, so I have the results table here. And also the zinc one, the theoretical value is about 1.116. And I don't write down for the Vaseline vase. So I want you to do a little more research. And once you find the energy, identify the isotope that's emitting that gamma ray. And basically this is the results table, and the top half, that's for the known gamma ray source, and the bottom part, this is for the unknown one. And so for this lab you use Log Pro to find the channel number, and use Excel to find the calibration function. Use the calibration function to calculate the energy of the gamma ray for the unknown sources, and then use that unknown source to identify the isotope and calculate the percent error. So if you can't find the source, that's all right. You can keep the, as long as you found the experimental energy. And this one I do require a lab report and formal lab. This will be our last formal lab report, and it's due next Sunday night. So feel free to contact me if you have any question. And because there are lots of new information here, don't panic, and contact me if you have any question. Email me, or we can schedule Zoom meeting like this. Thank you. Good luck. Have fun. Stay healthy. See you next week.